Yes, dear friends, in this video, I will take electric field due to dipole. Electric field due to dipole at any point on right bisector of the axis of dipole or equatorial point. Why equatorial word is used here? Actually, dipole, you can see here plus, suppose minus q charge plus q charge. Axis dipole is this. So bisector may only you can think this way. It is also at right angle to this direction and this direction. Means here dipole plus minus q plus q. तो ये जो plane है which is this plane which is perpendicular to axis is called equatorial point. Whether I take here or here or here or here, that will be always the line joining this here. It is point P. Here minus q charge, it is plus q charge, distance 2a. So it 2a to a, this is a. So this line is the right bisector. So electric field due to plus q charge at P will be along this direction, E1, and it is E2. It is minus charge. So electric field is the force on unit positive charge. If I take here plus 1 coulomb charge attracted this way, repelled by this way. So these are the two. So this point don't mean it is right bisector only on a line. This line may lie in a plane which is right bisector of the axis, and that is called equatorial plane. So here we have to find out electric field. So this heading clear, electric field due to dipole at any point on right bisector of axis or equatorial point. I am rubbing this heading because I need board clear. So the magnitude of this distance, because it is right bisector, so AP equal to PB. These two distance equal magnitude of charge plus q and minus q same. So magnitude of electric field E1 magnitude equal to 1 upon 4 pi epsilon 0 q upon AP square. AP square equal to A square plus R square. So I write here R square plus A square. Similarly, magnitude of E2 again 1 upon 4 pi epsilon 0 q upon R square plus A square. I have not mentioned minus sign because I am tracking magnitude of E2. So these two magnitudes are equal, then but angle between their direction is this much. Since OP right bisector, so this BP equal to AP, the two angles are equal. Now there are simple method to find the resultant of two vectors which make the angle theta. Law of parallelogram can be used, but here a simple method is there. We resolve vector E1 and E2. Actually, if I complete this parallelogram, I get this. The resultant of these two will be along this direction. Since this side equal to this is equal to this. So this diagonal, suppose this diagonal is PD, I write PD. Bisect this angle, so this angle theta, this is theta. Here I can resolve E1 and E2 into rectangle components. This is E1 sin theta. This is E1 this side, E1 cos theta. And similarly E2 sin theta. And it is E2 cos theta. Since magnitude of E1 E2 equal है, this angle are equal, तो E1 E2 cancel each other. E1 E2 cancel, but E1 cos theta, E2 cos theta are in the same direction. You can make note of this or should I hope have you got my point? You can start like this. Let plus minus q charge are placed at point A and B at distance 2a. So this form dipole. To find electric field at P with the point P which is lying in the equatorial plane, we find first electric field due to plus q charge E1 along this direction, because electric field direction is the direction of force on positive charge. Positive charge will repel and it will be attracted. So E1 this side, E2 this side. The magnitude are equal. Now if two vectors are represented along the sides of parallelogram, then diagonal will represent their vector addition. So this PD diagonal of this parallelogram will represent the vector sum of E1 and E2. Here you can apply law of parallelogram also. So you can write here, you can resolve component E1 sin theta, E2 sin theta, E2, and so on. By E1 cos theta is the component of E1 along this diagonal. E2 cos theta is the component of E2 along diagonal. Now, since E1 sin theta and E2 sin theta are equal in magnitude, and opposite in direction, so the two cancel each other, while E1 cos theta and E2 cos theta are in the same direction. Along diagonal. So resultant field at P. So electric field at P E is equal to, I write here E equal to 1 upon 4 pi epsilon 0. Am I? Sorry. First I write E1 cos theta plus E2 cos theta minus here and P cap. P cap is unit vector. In the direction of vector P, means electric dipole moment के along होगा ये. Now putting the value of E1 E2 here, cos theta is this triangle, or in this triangle base upon hypotenuse. So we get here vector E equal to minus क्यों लगाया? Because this E is the opposite to P cap. P cap points from negative to positive. Direction of dipole moment of electric dipole is from negative to positive. So minus sign is necessary here. So you can write E1 plus E2 cos theta p cap. It is minus 2 upon 4 pi epsilon 0 q upon r square plus a square. Why I write it like this? E1 1 upon 4 q upon r square plus a square, E2 will be the same. So twice होगा. Cos theta base upon hypotenuse. Base is a. Hypotenuse is this. It will be r square plus a square to the power half. P cap. Actually, in board exam, people ask it in vector form. Vector form must have. After, if you don't get this thing clearly, I am trying my best. So you can read the book. This is 2aq minus 1 upon 4 pi epsilon 0 2aq upon r square plus a square to the power 3 by power 1, and this is half 1 and half 3 by 2 or into p cap. But 2aq equal to p, magnitude of electric magnitude of dipole moment. Dipole moment now has become very common term for you. It has been used many times. So P equal to 2aq is the magnitude, and if you write vector P, that will be 2aq into p cap. P cap point negative to positive. So vector E equal to minus 1 upon 4 pi epsilon 0 p dot p cap upon r square plus a square raised power 3 by 2. But p into p cap will give you vector p. Vector p means dipole moment. Sorry, vector p upon r square plus to the power 3 by 2. This is the electric field due to dipole at any point in equatorial plane. I remember 2 times it has been asked, write in vector form. What is this minus sign indicating here? This minus sign indicates here that vector E and vector P are anti-parallel. Vector E and vector P are anti-parallel. Now, actually here this diagram little become complicated. So listen to me. अगर ये हमारा डाइपोल माइनस क्यू प्लस क्यू चार्ज, तो फील्ड कम लाइक दिस रिजल्टेंट फील्ड, ये ई फील्ड जो है ऐसा आता है, तो ये राइट बाइसेक्टर है. तो पीपल स्टूडेंट थॉट कि दिस डाइपोल पी और ये ई पैरेलल है ना, लाइंस पैरेलल हैं, वेक्टर पैरेलल नहीं है, क्योंकि वेक्टर पी तो इधर है और वेक्टर ई इधर है. तो एट राइट बाइसेक्टर इलेक्ट्रिक फील्ड टू डाइपोल इज एंटी पैरेलल इलेक्ट्रिक फील्ड. And student wrote, when the question was asked, what is the at which point electric field to dipole is parallel to dipole moment. So student wrote like this: at right bisector, at every point on right bisector, electric field is parallel. It is not parallel. Parallel, so it will be along axis. At every point on axis, dipole moment from left to right. Here electric field this way, electric field this way. Actually, we keep on learning derivation, but in exam, the people ask simple question the concluded part. तो concluded part क्या होगा कि वेक्टर E इक्वल टू -1/4π0 P अपॉन R स्क्वायर प्लस A स्क्वायर पावर 3/2. Now the minus sign, I am repeating again, indicates that at right bisector or in equatorial point of dipole, electric field is anti-parallel to dipole moment. If R much greater than A, negligible. कैसे? Suppose R is 1 meter and A is 5 millimeter. So 5 millimeter negligible is more. Then vector E will be how much? 1/4π0. You can write minus here also. R cube. On axis it was 2p upon R cube, but plus sign था. Magnitude of electric field at here E magnitude. When you want to write, you can write 9 vacuum में this P upon R square plus A square to the power 3/2. When you are finding answer magnitude of electric field in numerical problem, you can write directly this thing, because you know 1/4π0 is equal to 9 × 10⁹. Or at far point, when R much greater than A, this is called far point also. So E is equal to 9 × 10⁹ or P upon R cube, because A negligible ना, R square to the power 3/2. The number power to the power get multiplied, R into 2 into 3/2. So 2 get cancelled. So you get R cube. So these are important topics of your syllabus, and certainly there will be question. Now I told you कि राइट बाइसेक्टर पर फील्ड ऑलवेज एंटी पैरेलल, यानी कि हमारा ये डाइपोल है -q + q, ये राइट बाइसेक्टर, ये एक्सिस है, ये राइट बाइसेक्टर है भाई. तो एट राइट बाइसेक्टर इलेक्ट्रिक फील्ड एंटी पैरेलल, तो यहाँ ये होगा. तो यहाँ पर फील्ड की डायरेक्शन क्या होगी? अगेन दिस वे. So many times this question is asked, what is the magnitude and direction of electric field at midpoint of dipole? For this distance we take 2a. So generally -q + q confuse the student and they write zero answer. Zero नहीं है, फील्ड लाइन कैसे होती है? यहाँ पर जो फील्ड होगा टोटल magnitude होगा 1/4π0 2q upon a square. 2q upon a square. कहाँ? At midpoint of dipole. Please note it. And direction from positive to negative. By field in the force on positive 1 coulomb charge. This positive charge repels this way, this attracts this way. Both get added. Please keep in mind it is vector quantity. So I think you have enjoyed this topic and practice it. प्रैक्टिस से ही होगा सब कुछ. नाउ आई कम इन नेक्स्ट वीडियो फॉर अनदर इम्पोर्टेंट टॉपिक.